Hi everyone, we're continuing with section 4.7 and we're going to do examples for group 2 of the inverse properties. Now for these, if the angle theta is looking over at this outer inverse trig function, and if we have a pair of partner inverse functions here, like inverse sine and sine, if theta is in the range of the outer function, in this case inverse sine, then theta will be the final output, the final answer, what this simplifies to. So you have to know the ranges for inverse sine, inverse cosine, and inverse tangent. Notice that the acute angles from 0 to pi over 2 are all in all of these ranges. So if theta is acute, then certainly theta is the final output. So for example, take here pi over 10. Pi over 10 is an acute angle, it gets spit out. Pi over 10 asks this outer function, inverse sine, am I in your range? And by the way, inverse sine and sine are corresponding inverse functions. They're partners. Pi over 10 asks the outer function, inverse sine, am I in your range? Inverse sine says, yes, you're between negative pi over 2 and pi over 2. Well, certainly you're acute. So the acute angles work for all three of these cases. I will spit you out, pi over 10. So this entire expression simplifies to pi over 10. I don't even care what the sign of pi over 10 is. It's an irrational number. As a decimal, it goes on forever and ever. The final answer is pi over 10. So if theta is any angle inside this interval, this range for inverse sine, then that value for theta is the final output. Now, if theta is not in the range of this outer function, then the result could either be some other quadrantal angle, some other brother or coreference angle, or undefined. But the answer will not be theta. If theta is not in the range of the outer function, then by definition of the range, this outer function is not allowed to spit out that value for theta. You're going to get one of these. Now, it's not so much that you have to remember these three possibilities if theta is not in the range. It could be just a matter of you working it out and you see what you get. So for example, let's consider the inverse sine of the sine of 5 pi over 6. The inverse sine of the sine of 5 pi over 6. Now, will this property up here in the upper left work for this value of theta? Well, 5 pi over 6 is not acute, so I'm a little suspicious. 5 pi over 6 as this outer function, and by the way, inverse sine and sine are partner inverse functions. 5 pi over 6 asks this outer function, am I in your range? Inverse sine says, 5 pi over 6, well, that's not between negative pi over 2 and pi over 2. In fact, you're not even in the right quadrant. 5 pi over 6 is a quadrant 2 angle. And certainly quadrant 2 angles are not covered in the range for the inverse sine function, so I know that the answer will not be 5 pi over 6. So one way that you can work this out and get the correct angle is to just do it brute force. Do it step by step. What is the sine of 5 pi over 6? It's 1/2. The inverse sine of 1/2 is pi over 6. So you can go step by step and figure this all out. But there's a faster way of doing this. If you think that these steps might be a bit too tricky, there's a fast way of doing this. Consider the unit circle. Now, 5 pi over 6 is a quadrant 2 angle over here. And it does have a sine value. But the problem is that 5 pi over 6 is not in the range for the inverse sine function. Unlike the case for pi over 10. You see, for pi over 10, pi over 10 asks arc sine, am I in your range? Pi/10 asks arc sine, am I in your range? And arc sine, inverse sine says yes, so Pi/10 gets spit out. But over here, in this example, 5 pi/6 is not in the range of inverse sine. It turns out that, notice, the answer is a brother for 5 pi/6. But which brother is it? We need a brother with two properties. We need a brother with two properties. We need a brother that has the same sine value as 5 pi/6 does. Now, I hope that you know, or that you can figure out, that sine of 5 pi/6 is 1/2. But just like it didn't matter what sine pi/10 was numerically, it doesn't even matter what sine 5 pi/6 is exactly. I hope you know it's 1/2, but you don't even have to know that for this example. You know the answer here is going to be a brother. 5 pi/6 is not quadrantal. We don't think the answer will be quadrantal. And this will all work out. The answer will not be undefined. The answer is going to be some other brother or coreference angle. We want a brother or coreference angle with two properties. We want a brother with the same sine value that 5 pi/6 does. It turns out that sine value is 1/2, but that doesn't even matter. We're going to use symmetry. We're going to use symmetry. Well, whatever the sine of 5 pi/6 is, it's the y-coordinate of this point over here. What other point on the unit circle has the same y-coordinate? Over here. That y-coordinate is 1/2, but we don't even have to know that. I need a brother angle in quadrant 1. I need a brother angle in quadrant 1. But what brother do I want? We need a brother that is in the range of, in this case, the inverse sine or arc sine function. What's the range for inverse sine or arc sine? From -pi/2 to pi/2. And what is the only angle in this range that's a brother to 5 pi/6? The final answer is pi/6. And that is our final answer. It's the only brother for 5 pi/6 that has the same sine value. We want a quadrant 1 angle, not a quadrant 4 angle. And it's in the range for the inverse sine function. It helps that pi/6 is acute. Because we know that the sine value has to be positive, we know that the final answer is going to end up being acute, since this is not quadrantal. All right. So you could either work this out brute force. Sine of 5 pi/6 is 1/2. The inverse sine of 1/2 is pi/6, or just use symmetry. You need a brother with the same sine value, in particular, the same sign, SIGN for the sine value, positive as opposed to negative in this case, and it's got to be in the range for the inverse sine function. All right.